G'day guys, Michael Woolhouse from ABCPE here, the site where we make VCE/PE as easy as ABC. Today we're talking about Newton's three laws of motion. What we'll do is we'll flip between a little bit of information, a little bit of a video, and then a bit of a question. Hopefully this helps. So Newton's three laws, the first one's probably the easiest one to remember. The body will remain at rest or in uniform motion unless acted upon by an external force. All right, let's look at that in action.
G'day guys, Mike Woolhouse from ABCPE here, the site where we make VCE/PE as easy as ABC. Today we're talking about Newton's three laws. Newton's first law is the law of inertia. What this law says is that ball will remain in its constant state of motion unless acted upon by an external force. In this case, the external force is going to be me, and I'm going to move.
So nothing spectacular there, besides great acting, obviously. But all we're trying to do with this law is that we've got something stationary or in that constant motion. We've just got to move it. So if we go back to our PowerPoint here, let's have a crack at a VCAR question. So here's from 2019. I'll give you a sec. Don't overthink this, is our advice. When we've got a 2-mark question about Newton's first law, our first point of call should be a definition. And then our second point of call should be, how does this relate to this activity? In this case, a free throw. So I'll give you a second to do this. Okay, our first sentence should be the law of inertia, and we've got to define it. I think with your definitions, it's important that you guys really nail these. And the second mark probably seems a little bit too simple. But what we're looking at is that the ball will not move unless acted upon by the force of the player. You could have also gone, well, the ball will continue in its motion until it hits the ring or the backboard, etc. But you just had to have that explicit link to a free throw. And not super well understood. We're still getting like a 1.4 average, but this is a point worth noting. Just saying the law of inertia, that's not enough. You need to give the full definition. Okay, Newton's second law. This is a tougher one. Look, a force, it's the starting point should be, it's the law of acceleration. So the acceleration of an object will be directly proportional to the force applied on that object. So let's break this down a little bit. Acceleration of object, so how quickly it will change its velocity, is going to be directly proportional to the force I apply. So that means as force goes up, acceleration will go up. As force goes down, acceleration will go down. We do these fingers, and you might find it annoying, but I think it gives you a good visual that directly proportional means as one goes up, the other one goes up. As one goes down, the other one goes down. So that's directly proportional. Small force, small acceleration. Big force, big acceleration. Secondly, inversely proportional to the mass. So what that means is, as mass goes up, acceleration goes down. So inversely proportional means as one goes up, the other goes down, but it can also be the other way. As mass goes down, acceleration will go up. So what it means is a heavier object will accelerate slower once the force is the same, whereas a lighter object will accelerate faster. So mass down, acceleration up. Light object will accelerate faster. So again, just using that definition, just using that equation, is not enough. You need to give that full sentence. And let's have a look at this in reality.
Okay, now we're going to Newton's second law. This is the law of acceleration. This law says that the acceleration of an object is directly proportional to the force that you apply. So if force goes up, acceleration will go up. It also says that the acceleration of an object is inversely proportional to its mass. So if mass goes up, acceleration will go down. Here we have 3 different weighted balls. Over here we've got 7.
Just going to stop that there. Often what will happen here is that we're always going to give, or hopefully VCAR and your teacher is going to give you something that stays the same. So this time I'm going to try and have the same force each time. So force equals MA. If force remains constant, we are changing the mass of these balls. So you have to work out what that will do with the acceleration.
Kilograms worth of mass, and down here, very little. What I'm going to do, I'm going to apply the same force on each of these three balls, and let's see what happens to the acceleration. Lightest fall. Middle
Big
ball.
acceleration.
And
Medium
now
acceleration.
the ball with
goes
the
a bit
real
heavier.
heavy mass, same force. Very little acceleration.
So very little acceleration there. Okay, this one is from 2018, VCAR. This was the first year where biomechanics was in it. So we struggled a little bit to know how they're going to ask it. It's a bit easier for us now, but have a look at B. A is like one that is almost general knowledge. So we won't even teach our kids A in a great deal of detail because hopefully everyone knows that we've got gravity, we've got air resistance, in particular that are working on those cyclists. But B is what we're looking at really. And I'll give you a second to have a think about this. Please read the question carefully because it's got a pretty good clue. It gives us two bits of information. I'll give you a second to think about it before I give you the answer. The first bit of information is that one cyclist is accelerating faster. The other bit of information that's really crucial is that the overall force acting on them is the same. So with F equals MA, they've given us the A part. They've also given us the F part. So the M is what you're going to have to talk about. Have a crack at this one. All right, so again, we would go deep on all these questions. So start with your definition. It's the acceleration object will accelerate in directions of force applied, directly proportional to the force. Acceleration will go up, force goes up, and inversely proportional to the mass. Please always use the definition as your starting point. As your second point, please use the equation. Now, force is the same, but we know the cyclist ahead is accelerating faster. So there's only one possible explanation for this, is that that person has the lighter mass. So if you started talking about, well, they must apply a greater force or they're not accelerating as fast or whatever, you've overcomplicated it. What you've got to know is that VCAR have given us 2 points. You've just got to fill in the blanks for that third point. In this case, mass, and it has to be that the cyclist in front has that lower mass. Only 15% of the state could get 2 out of 2 here. A lot of people missed that definition mark, but a lot of people also couldn't make that explanation. Try not to overcomplicate it. Biomechanics is tough. Try and just say FMA. The equation is a perfect checkpoint for you to tick off that you've talked about in your answer. Okay, Newton's third law is probably the one that the students understand the easiest, and it's the law of action reaction. So for every action, there's an equal opposite reaction. The harder we push down against something, the more reaction force there'll be. So most likely this will be asked in terms of a gymnast or a diver or a trampolinist, that the more action force we can put into an object, the greater the reaction force, which means we'll have end up higher in the air. So easier for us to do our flips or our somersaults, whatever it is. All right, let's have a look at this.
Finally, Newton's third law. This is the law of action-reaction. For every action, there is an equal and opposite reaction. We think this is best explained on a trampoline.
This is my little daughter, Charlie.
Here we have Charlie again. She's going to put a little
Nice and
action
nervous
force
here.
into this trampoline, and let's see what the reaction force is. So little action
Small
force,
action
a little equal
force,
and opposite reaction force.
equal
Going in
and
the same
opposite
direction
reaction
that
force
she's
is also
pushing,
small.
which is down, the reaction force is coming up. Now she's going to do a big action force, and consequently we have that bigger reaction force, means higher jump. Good job.
All right, because this is a fairly easy concept, we've tried to give you a harder question here. So explaining using Newton's third law how the blocks will affect this performer. 3-mark question. The first mark is going to be for your definition, then the explanation. There's no equation for Newton's third law, and then performance. Pause the video now and have a crack. Okay, so let's tackle this. We'll give you the explanation here first. So Newton's third law says for every action, there is an equal and opposite reaction. Now, with the blocks or without the blocks, the force generated will remain pretty similar. This is the same athlete. They've got the same muscle mass. They've got the same percentage muscle fiber types, etc., etc. What is different is that the action force will be applied in a more horizontal direction, which means the reaction force is going to push this sprinter more in the direction with which she wants to go, which is 100 meters that way. So this is going to be more beneficial compared to if we don't have the blocks, we're going to have a more vertical action reaction force, which is not pushing us in the direction that we want to go. So it's going to be slightly slower. It's not going to be a huge difference, but if you're a 100-meter sprint at the Olympics, it's certainly going to be enough difference to cost you a spot in the final, a medal, etc., etc. So, how do we write this down? We're starting with the definition. Newton's third law states for every action is equal opposite reaction. There's no equation for this law. So, what we're really getting at is that we're applying that force in the horizontal direction. So, we're more going where we need to. And don't forget the easy bit. Faster start means she's going to finish that race in a quicker time. Therefore, she's more likely to win the race. So a 3-mark question from us, and that's Newton's 3 laws. That's probably as hard as you're going to get on Newton's 3 laws. So hopefully you can, if you understand that one, you're going to be in great shape. Often how it's come from VCAR is applying more force into the ground, gives you more reaction force, means you can jump higher, but you never know what's going to happen up next. So thanks for listening. Hopefully that made Newton's 3 laws as easy as ABC, and we will speak to you soon. Cheers, guys.